Okay, so today we're going to look at the impact of geographical distribution on what we know about evolution. So what do we mean by this? Geographical distribution refers to the discontinuous distribution of plant and animal species on the continents across our world today. So what that means is that we have different plant and animal species in different places all over the world. So we actually have species that are very similar ecologically, so similar in the structure and behavior, but they're in very separate areas across the world. For example, fossils of the Lystrosaurus, which you can see in this picture here, have been found in South America, India, and Antarctica. And as you know, these are very separate areas across the world. So how come we can see similar species in very different places around the world? Okay. So it was actually in 1912 that this man called Wegener suggested that today's continents were once one big landmass before they all drifted apart. We call this today the theory of continental drift. As you can see in the picture on the side here, this is what scientists theorize the world used to look like before all the continents drifted apart, and we actually used to call this, or we call this today, Pangea. So the fact that we do have this discontinuous distribution of fossilized and living organisms, so species that have died out and species that are still living today on different continents across the world, supports this theory of Wegener. Okay, so the theory of continental drift. So initially Wegener's theory was not actually received favorably, as many scientific theories have been in the past, which have later been believed to be correct. And this was because we didn't have a good understanding of the Earth's layers and how these layers and the deep ocean floor actually worked. Okay, so Wegener's theory was actually revised and expanded into the theory of seafloor spreading and plate tectonics. So we know a lot about plate tectonics now. You can see in the picture below that they're the tectonic plates across the world, and it's actually these lines where the plates join, which are called active zones. And it's across these active zones that we have a lot of volcanic activity and earthquakes and things like that, as you can imagine, with tectonic plates bumping into each other and things like that happening. So plate tectonics, you probably know a bit about these. So we, as scientists, we believe that, or the plate tectonic theory states that the Earth's surface is divided into different layers. We have these crustal plates that are just below the surface, or in the top layer of the Earth, and they float on a molten mantle. Okay, so these plates are actually, and this is where the tectonic plates are, just above the mantle, and these plates are in constant slow motion, so very, very, very slow, only moving a few centimeters apart a year, which is not much at all. And the reason that these plates actually move is because down the bottom in the picture, you can see the core of the Earth is actually extremely, extremely, extremely hot, and it creates convection currents in this molten, or essentially liquid, mantle. So that means that you get the heat, the liquid hot bottom layer rising, and then cooling towards the top, and then dropping back down. And that's to do with the density caused by heat. So this causes these plates to move, and again, it is where on these active zones where the tectonic plates meet that you get mountains forming, volcanoes and earthquakes occurring. Now if you look back, let's go back. Oh, we're not allowed to. Sorry for that. Okay, if you look back, you can see that Australia is not actually in an active zone, and that's why we don't get too many we don't get volcanoes and earthquakes. All right, moving on. And that's it. Well done.